Okay, next topic is fundamental requirements of protective relay. So the fundamental requirements are selectivity, speed, sensitivity, reliability, simplicity, and economy. So these are all the first fundamental requirements of protective relay. Let us discuss one by one. Selectivity. Let us start with selectivity. Now, the protective relay that is used for sensing the fault, it must be able to select correctly the part of the system where fault has occurred. Okay, and disconnect the faulty part without disturbing the rest of the system. Okay, so selectivity means the faulty section, okay, of the system must be accurately selected by this protective relay. Okay, so if this protective relay is able to select correctly the part of the system where fault has occurred, okay, then we can say that this protective relay has good selectivity. Okay, so it must be able to distinguish between the faulty section and the healthy section. Okay, so unnecessarily the circuit breaker which is in the healthy section should not be operated because of this relay. Okay, so you should not cause to operate the circuit breaker which is under healthy section, but it should select accurately the faulty section, and it should be able to immediately give signal to the circuit breaker which is in the unhealthy section. Okay, that is known as selectivity. Next is speed. So electrical apparatus may be damaged if they are made to carry the fault current for a long period of time. Okay, so whenever fault occurs, okay, and if this fault current persists for longer time in the system, okay, then the apparatus connected in that zone may get damaged. Okay, so as soon as fault occurs, okay, so it must be quickly sensed by this relay. Okay, the speed of the relay should be high enough to quickly sense the fault. Okay, so if fault persists for longer duration of time, and if the electrical apparatus in that faulty zone are damaged, then it may even shut down customers' motors and generators, making them unstable. Okay, so the fault must be cleared as quickly as possible. Okay, so the relays that we are going to use, they must be high speed relays. Okay, so if we are using high speed relays, then it will decrease the possibility of development of one type of fault into some other severe type of fault. Okay, if there are chances for development of one type of fault into another type of fault if the fault is left for longer duration of time in the system. Okay, so the relay should have high speed. Next is sensitivity. The volt ampere input required by the relay coil of the relay must be low. Okay, you already know we have discussed about the basic relay operation. So in that we have discussed that whenever the relay coil is energized, what will happen? The relay moving contact will come in contact with the relay's fixed contact. When the relay moving contact comes in contact with the fixed contact, what will happen? The trip circuit will be closed. When trip circuit is closed, the DC source, the source in the trip circuit will energize the trip coil. Okay, so it may be a DC source. So it will energize the trip coil. When the trip coil is energized, circuit breaker contacts are open. Okay, so the volt ampere input required by this relay coil must be low. Okay, smaller this volt ampere input required by this relay coil, more sensitive will be the relay. Okay, so if the volt ampere input required by the relay coil is small, that means that relay is more sensitive. Next is reliability. So reliability is the ability of the relay system to operate under predetermined conditions. Okay, so of course faults are unpredictable. Okay, we can't say when will fault occur in the power system, at what location fault will occur. Okay, we can't decide the location and time of the fault. Okay, so the ability of the relay to operate under predetermined condition is known as reliability. Without reliability, the protection would be inefficient. Okay, so ineffective actually in correct words, if you want me to say. Okay, so protection will be ineffective if the reliability is not there. Okay, so the relay should be reliable. Okay, we must rely on the relay. Okay, so next one is simplicity. Okay, if the relay is simple, then maintenance will be easy. Okay, so that's why relay should be simple for easy maintenance. Okay, reliability is closely related to the simplicity. Okay, simpler the protection system, greater will be its reliability. Okay, simpler the protection system, its reliability will be greater. Next factor is next fundamental requirement is economy. So the most important factor in the choice of the particular protection scheme is the economic aspect. Okay, so the protective gear should not cost more than 5% of the total cost of the whole equipment which is to be protected. Okay, so if you want to protect a generator, okay, so whatever protective system that you want to connect to that generator now to protect it from faults, okay, so in that protective system there will be a circuit breaker and relay. Okay, and this protective system cost should be only 5% to the total cost of the equipment which is to be protected. Okay, however, when the apparatus is to be protected is of utmost importance. Okay, when it is of utmost importance, okay, for example generators, main transmission lines, etc., economic considerations are often subordinated to reliability. Okay, so means the cost can, we can neglect the cost of the protective equipment whenever we want to protect higher rating generators and transmission lines. Okay, so these are all the fundamental requirements of protective relays. Next, zones of protection. Okay, so you can see here in this image, this dotted lines, this dotted boxes, I can say, they are the zones. Okay, so if you see here, this black dotted line represents the generator protective zone. Okay, this green dotted lines represent the generator transformer protective zone. Okay, so this red color dotted lines represent the bus bar protective zone, and this blue color represents the transmission line protective zone. Okay, so these dotted lines in this image shows the protective zones. So zone of protection are separate zones which are established around each power system equipment. Okay, so these zones of protection are established across each power system equipment. So when fault occurs on any of the protection zone, then only the circuit breaker within that zone will operate. Okay, so in any of this protection zone, if fault occurs within this protection zone, whatever circuit breaker is there, that circuit breaker will operate. Okay, thus only the fault element will be isolated without disturbing the rest of the system. Okay, so other means the equipments which are in the other zones will remain, means they will perform their own normal operation. Okay, So they will perform their own normal operation. There will not be any disturbance in their operation. Okay. So the production zone covers the entire power system, and no part of this, no part of the part of any equipment in the power system is left unprotected. Okay. So in the power system, no part is left unprotected. Okay. So protection zones will cover each and every equipment in the power system. Okay. So it usually consists of one or more elements of the power system. Okay, so it may consist of one element. Means if you see here, there is in this zone, in this black dotted box, you can see only generator. So it is protecting only one equipment here. Okay, so in this zone, you can see in this green box, within this green box, you can see a generator and transformer are there within this. So this is protecting both generator as well as transformer, this zone. Okay. So the protection zone of this power system mainly depend upon the rating of the machines. Okay, protection zones of the power system will depend only upon the rating of the machines, its location and probability of fault and abnormal condition of the equipment. Okay, so protection zones of the power system will depend upon the rating of the machines, its location, probability of fault. Okay, so if you consider this transmission line, the chances are, since the lines are open, okay, the chances of occurrence of the fault is more. Okay, chances of occurrence of the fault in the open air will be more when compared to indoor equipments. When compared to indoor equipments, outdoor equipments will face more faults. Okay, so the probability of fault occurrence will be more in the transmission line. Okay, and abnormal conditions of the equipment. Okay, so all these factors will affect the protection zones of the power system. Okay, so due to overlapping, if you observe here, all these zones are overlapping each other. Okay, all the production zones will be overlapping each other. Okay, since these production zones are overlapping each other, if fault occurs in the overlapped zone, okay, so if you see this red color and this green color, you can see they are overlapping. So if a fault occurs in the overlapped zone, then there are chances for unnecessary tripping of breaker, even though okay, so unnecessary means since fault has occurred in the overlapped zone, okay, so unnecessarily some other circuit breaker may open. Okay, so because more number of circuit breakers are there, so actually this circuit breaker is used to protect transformer and the generator within this. Okay, but it is also in the zone of busbar protection zone, this circuit breaker, this particular circuit breaker. So if fault occurs in busbar in the busbar zone, okay, so if fault has occurred somewhere else or somewhere here else, if some other circuit breaker is about to interrupt the fault, okay, so this circuit breaker may unnecessarily open. Okay, but even though unnecessary operation of these circuit breakers may occur, but due to security reasons, okay, overlapping of the protective zones is done. Okay, so actually no need to okay, theoretically no need to overlap the protective zones, because each and every equipment is provided with its own protective system. Okay, but for security reasons, if suppose two circuit breakers are here, you can see here. So if fault has occurred nearby to this circuit breaker, then this circuit breaker should operate, not this circuit breaker. But if this circuit breaker fails to operate, with some time delay, this circuit breaker will operate. So time setting will be provided depending on the location of the fault. Okay, so that's why overlapping of the zones is very, very important. Okay. And usually the boundaries of these protection zones are decided by the location of the current transformers in the power system. Okay, look at by the location of the current transformers. In this image, you can't see any current transformers. It's just simply zones of protection are shown here. Okay, current transformers are not shown in this image, but by location of the current transformers, zones of the protection zones, boundaries. Okay, zones means, I'm sorry, boundaries of these protection zones are decided. Okay, and all these protection zones will be overlapping with each other to ensure complete safety of each and every element of the system. Okay, in order to ensure complete safety of each and every element of the system, all these protection zones are overlapping each other. Okay, if suppose if there is any zone which is left unprotected, okay, of course it is not left unprotected, no zone is left unprotected, but if any zone within the power system is left unprotected, then that zone you will call as dead spot. Okay, unprotected zone is known as dead spot. Okay, unprotected zone, if it is there, then it is known as dead spot. Okay, since all the protective zones are overlapping each other, definitely there will not be any dead spots dead spot in the power system. Okay, all the protective zones are overlapping, therefore there will not be any dead spot in the power system. Okay, so the circuit breakers are located in connection to each power system element, and hence the fault when fault occurs, only faulty section is disconnected. Okay, you can see only, mostly you can see the circuit breakers here. Okay, so since the circuit breakers are connected to each and every power system equipment, so whenever fault occurs, only faulty section will be disconnected instead of the healthy section. Okay, so this is about the zones of protection of the power system. Okay, let us discuss this next topic, that is primary protection and backup protection. Okay, so the protection provided by the protective relaying equipment can be categorized into two types. Okay, the protection which is provided by this protective relay equipment can be categorized into two types, that is primary protection and backup protection. So let us discuss about this primary protection first. So it is the first line of defense. Okay, so when fault occurs, okay, in the power system at any location, this primary protection is the first line of defense, and it is responsible to protect all the power system elements from all types of faults. Okay, so the primary protection is responsible to protect all the power system equipments from all types of faults. So when the primary protection is inoperative for any reason, okay, if primary protection fails to operate, okay, or it is inoperative for any reason, then the backup protection have to sense the fault and trip an appropriate circuit breaker. Okay, so there will be backup protection if primary protection fails to operate. Okay, so whenever primary protection fails to operate, backup protection will sense the fault and it will trip the appropriate circuit breaker. Okay, so now I have told you that if primary protection fails to operate. So there are many reasons due to which primary protection may fail to operate. Okay, those reasons are failure in the circuit breaker, failure in the protective relay, loss of voltage and current supply to the relay. Okay, so if circuit breaker fails to operate, okay, and failure in the protective relay itself, okay, relay itself fails to operate, loss of voltage and current supply to the relay. Okay, so the current required to energize, voltage or current required to energize the relay is lost. Okay, failure in this trip circuit. Okay, so if the trip circuit fails to operate, okay, then we can say that primary protection has failed to operate. Okay, so failure in the circuit breaker means the breaker cannot operate due to jammed contacts. Okay, so the actually as soon as fault occurs, as soon as trip coil is energized, okay, so what should happen? This moving contact should move away from the fixed contacts. If these fixed contacts and moving contacts have jammed, okay, then moving contact cannot move away from the fixed contact. Okay, of course, in this image, the contacts are away from each other, fixed contact and moving contact are away from each other, but under normal operating condition, as you people already know, the moving contact will be in contact with the fixed contact. Okay, if there is failure in the circuit breaker, that may be due to jammed contacts. Jammed contact means the moving contact won't be able to move away from the fixed contact. Okay, next is failure in the protective relay. Okay, so if the relay setting is not properly done, then it cannot sense the fault. Okay, so relay setting will be done. There will be time setting will be provided. We have already discussed for the time for the relay to operate. Okay, so if proper setting is not provided to the relay, then it won't be able to sense the fault. Okay, so we can say that there is failure in the protective relay. Okay, or we can say protective relay has failed to sense the fault. Okay, next is loss of voltage and current supply to the relay. Okay, so if the protective equipment is supplied by DC battery bank, okay, if the protective equipment is supplied by DC battery bank, and if there is a fault in the supply itself, in the DC battery bank itself, there is fault, then the relay cannot be energized. Okay, if the relay is not energized, then it cannot generate the trip command to operate the circuit breaker. Okay, so that is known as loss of voltage and current supply to the relay. Next is failure in the tripping circuit. Okay, so what is the tripping circuit? Actually, it is used to transfer a signal from relay to the breaker, isn't it? The trip circuit, this is a trip circuit. It transfers signal from relay to the circuit breaker, and if the system has failed to operate, then circuit breaker will not open. Means because of some or the other reason, this trip coil is not energized. Definitely, the moving contact won't be able to move away from the fixed contact. Okay, so we can say there is failure in the trip circuit. Okay, so these are all the causes for failure of the primary protection. So we must we must have backup protection in order to protect the equipments if primary protection fails to operate. Okay, so backup protection is provided to protect the elements of the power system when the primary protection have failed to operate due to any reason. It may be any reason, there may be any reason. Okay, because of which the primary protection fails to operate. Just now we have seen some reasons. Okay, element which is to be protected, and if the primary protection fails to operate, then it is observed that in practice it is observed that it can cause severe damage in the power system. Okay, and therefore it is very necessary to implement the backup protection. Okay, so the arrangement of this backup protection is done in such a way that failure in the primary protection should not cause failure in the backup protection. Okay, so failure, if even if backup protection is provided, okay, in the system along with the primary protection, and if primary protection fails to operate, then backup protection also should not fail to operate. Okay, so it should means along with the primary protection, backup protection should also not fail to operate. Okay, so in order to avoid this, okay, in order to avoid failure in the backup protection is located at a different station from the primary protection. Okay, in order to avoid failure in the backup protection is located at a different station from the primary protection. Okay, so generally this backup protection is given to the costly equipments. Okay, so for cost and economic considerations, backup protection is employed only for protection against short circuits, okay, but not for any other abnormal conditions. Okay, so backup protection is not required for abnormal conditions which will persist for very short duration of very short duration of time, slight fluctuations in voltage or current. Okay, so for such conditions, backup protection is not required. Usually, it is given in the system where chances of short circuit are more. Okay. So let us discuss about backup relaying. Okay, so there are some methods of backup relaying. So those methods of backup relaying are relay backup protection, breaker backup protection, remote backup protection. Okay, so let us see this relay backup protection. Okay, in relay backup protection, what is done is there will be a single circuit breaker which is used by both primary as well as backup protection. Okay, means both primary protective system as well as primary protective relay as well as backup protection relay will be connected to single circuit. They will operate the same circuit breaker with some time lag. Okay, but the two protective systems are different. Okay, so both will not be connected in the same protective zone. One will be in one zone, another will be some other zone, but there will be some time delay. If this primary relay fails to operate, then backup relay will operate. The same circuit breaker, that is known as relay backup protection. Okay. Next is breaker backup protection. In this scheme, separate breakers are used. Okay, in breaker backup protection, separate breakers are used. They will provide. They are provided for the. Separate breakers are provided, are connected. I can say they are connected to the primary as well as backup protection. Okay, so two different breakers will be there. One will be connected to the primary, another will be connected to the backup relay. Okay, both type of breakers are in the same zone. Okay, both the breakers will be in the same zone. Okay, so both are not connected to the same circuit breaker, both the primary relay and backup relay. Okay, primary relay and the backup relay both are not connected to the same circuit breaker. In this case, one primary relay will be connected to some circuit breaker, another backup relay will be connected to some other circuit breaker. Okay, if primary relay fails to operate its circuit breaker, backup relay will operate its circuit breaker. Okay, so both these circuit breakers, since they are in the same zone, they will be able to protect whatever equipments are there in that particular zone. Okay, next is remote backup protection. Okay, separate breakers are provided for primary and backup protection in this case. Okay, separate circuit breakers are provided for primary and backup protection. The two types of breakers are at different stations. Okay, their zones of protections are different and are completely isolated and independent of each other in this case. Okay, so the name itself tells remote. Remote means they are completely isolated, they are independent of each other. Okay, so these three are the methods of backup protection. Next, operating principle of a protective relay. So the working of the relay is either depends on the electromagnetic attraction or electromagnetic induction. Okay, so the relay will work. The working principle of the relay mostly depends on the electromagnetic attraction, electromagnetic attraction type or electromagnetic induction type relay. Okay, of course, we are going to discuss different classification of relays. Okay, further. So this the relay can be either electromagnetic attraction type or electromagnetic induction type. If the relay is electromagnetic attraction type relay, then it will be having a solenoid. You know what is meant by a solenoid, which is attracted towards the poles of the electromagnet. Okay, so electromagnetic attraction type relay will have a solenoid which will be attracted towards the poles of the electromagnets. Okay, so these relays will work both on AC and DC supply, electromagnetic attraction type. Next type of relay is based on the principle of electromagnetic induction. Okay, such relays will use induction motor in which torque is generated by the process of electromagnetic induction. Okay, such types of relays will work only on AC supply. Okay, principle of protective relay, it can be either electromagnetic attraction type working principle or electromagnetic induction type working principle. So let us see the basic elements of the relay. So you can see here, we already know CT will be there, current transformer, or of course in the basic circuit we have seen only current transformer. Actually this current transformer or potential transformers are connected to the equipment which is to be protected. Okay, and signal from this current transformer, potential transformer is given to a sensing element. From this it is given to a comparison element. From this it is given to a control element, and this control element will close the trip circuit. Okay, so secondary of CT or PT is connected to sensing element. Sensing element is connected to comparison element. Comparison element is connected to control element. Control element is connected to the trip circuit. You know what is a trip circuit. Okay, so this relay is, basic elements of relay are sensing element, comparison element, and control element. Okay, these three are the basic elements of the relay. So what is the sensing element? Okay, so the sensing element will sense the abnormal conditions and faults in the protected zone of the system. Okay, sensing element, what it does is it senses the abnormal conditions and faults in the protected zone of the power system. Okay, next element is comparison element. This comparison element will compare the abnormalities of the system with a pre-selected relay setting. Okay, so in this comparison element, there will be already feeded pre-selected relay setting will be there. Okay, it will compare the abnormality of the system with the pre-selected relay setting. Next is control element. Okay, so control element is usually a switch. Okay, control element is usually a switch which gets closed and completes the circuit to trigger the circuit breaker and make an alarm signal. Okay, so in the basic circuit, what we have seen is there will be a trip circuit in which there will be moving contacts and fixed contacts. The trip circuit will be consisting of relay fixed contacts, and when the relay moving contact comes in contact with the fixed contacts of the trip circuit is closed, and hence trip coil is energized. Okay, so it is not necessary that there will be always trip circuit. There can even be an alarm signal. Okay, so control element can be connected to an alarm signal. Okay, so here in this image, of course, you can see only trip circuit. Instead of that, I can even write or alarm signal. Okay, so these are the three basic elements of the relay. So sensing element is used to sense the fault. Okay, comparison element will compare the abnormality of the system with the pre-selected relay setting value. Okay, so control element is nothing but a switch which gets closed and completes the circuit, either to trigger the circuit breaker or to make an alarm signal. Okay, so these are the basic elements of the relay.